Hello everyone, welcome to the physics class for the 6th class students. Today we are going to deal that measurements and the associated problems with units and measurements. All right. Okay, it's very clear. Yes, you would like to have the measurement of velocity and speed. So, if you are going to take that 1D motion, all right, the magnitude of velocity and the speed both are going to be same, all right, it's very clear. Yeah, in case of 1D motion, distance equal to displacement. Yes, or you agree? Speed and velocity, the units of speed and velocity are going to be same. Okay. At the same time, if you are going to get that magnitude is also going to be same. In case of 1D motion, the speed and velocity both are having the same magnitude. How it is confirmed? Let's see. In case of 1D motion, distance covered, you have to confirm that distance traveled by that body and the displacement both are going to be the equal. All right, it's very clear. Yeah. So, you will get that distance, you will get that displacement. Very clear. You can express either any of the units, you can get that meters or kilometers, whatever it may be, but you need to confirm that magnitude of speed and magnitude of velocity both are going to be same. But we have to consider the magnitude only, because if you are going to take that velocity, does it has the unit direction? All right, it's very clear. Specifically, it is going to get that direction. Okay, right, we would like to go for that. Yes, so you can measure that velocity, speed and all. Now I am telling you the relative, you have to get that relative velocity. If you are going to get that, the term relative means if you are going to compare the velocity of a one body which is going to be that another body, which is going to be from another frame of reference. It's very clear, you will get that. So, whenever you have seen two velocities are going to be comparable, you have to take that direction. If the two objects are going to move in this, you have to consider two objects in the same direction, in opposite direction we have to see. So, you have to confirm the relative velocity is that the velocity which has been obtained by the comparison with the another parameter, another velocity, just you have to take that same kind of the physical quantity. Just you have to take that. This is a one example. Let's see. If you are going to identify that these two trains are going to move, all right, it's very clear, you can measure that. Just you can compare that velocities, just you have to take that, it's going to be taken, right. So, these are moving in opposite direction. Yeah, what you have to see? Yes, you can take that. This is going to be comparable. You have to see that. This is very clear. Yeah, these two are going to be in the same direction. all right. These two are going to be in the same direction. Let's see. Yes, okay. The direction which plays important role while you are calculating that relative velocity, which are going to be in the same direction, which are going to be in the opposite direction. Let's see that they are going to move. So you can take that they are crossing each other, or either of one overtakes the first one. Just you have to see they are going to move in opposite direction. They are crossing each other. They are crossing the point. Just you are going to get overtakes, crossing each other. These are the different cases we would like to confirm. At that time, is it possible to get that relative velocity? Yeah, you have to take that. It's very clear. You would like to go for that. Yes, you have to take that relative velocity. You have to take this one. Yes, it's going to be VR. Yes, so V1 is the velocity, V2 is the velocity for that second one, this is for first one. All right. Yes, you have to take this one. This is very clear. Therefore, VR is equal to V1 minus V2. This is one case we can get this. We would like to measure the relative velocity. It's easy for you. You have to consider the direction. It's very clear. Both are going to be in the same direction. Let's assume. So, therefore, VR is equal to V1 minus V2. This is the case we have to consider. All right. Have you getting this point? Please have the look. It's very clear for you. First one and second one both are going to be in the same direction. It is the case for they are going to. Yes, suppose let us take the second one overtakes the first one. In that case, we would like to confirm that it will overtakes means it is going to move in the direction of first one. So, it is very clear both are going to be in the same direction. All right. Okay. Let's go for that. Yeah, this is one case we would like to take this one. Yes, now we are going to get that VR is equal to V1 plus V2. This is also one case. We have to see that V1, first one is going to move in this direction, second one is going to be in this direction. So, we would like to go for that V1 plus V2, that is going to be VR. Have the look into that case. This is the case which are going to cross the two trains. They are going to having that the crossing, they are crossing with each other. Just you have to confirm. It's very clear. So, okay, let's have the look into that matter. We would like to go for that. The relative velocity is going to be sometime more, sometime is less. It is very clear. It depends on the direction what we have been considered. They are going to be in the same direction, they are going to be in the opposite direction. Yes. So, mostly you will get the problems for the measurement of the relative velocity in case of the two trains or in case of a two moving objects which are in same direction, which are in opposite direction. You have to take that. So, one is crossing with each other and another one is overtakes the first one. Yeah, second one overtakes the first one. Just you have to take that. It's very clear. You have to take the problem. It's very clear. You can measure that. Two trains each of length 100 meter, very clear. Yes, you have to take this one. This is 100 meter. Okay. Each of the length is going to be 100 km or running on parallel tracks. All right. One overtakes the other in 20 seconds. All right. It's going to be, yes, you have to take that. The first one is going to be, is 100 meters. All right. You have to take that second one also. Second one is going to be just you have to see, this is very clear. This is also 100 meters. This is the second one, this is the first one. Overtakes and crossing each other, just you have to take. This is very clear. Yes, in 20 seconds and crosses the other in 10 seconds. They have given the time. Okay. Calculate the velocities of each of the train. That is very important. While you are going to take the measurement of that velocities, just you have to see. If they are going to get that total distance travelled, you have to get that total distance. Travelled. That is going to be considered 100 plus 100. Just you have to take that. That is 200. It's very clear. You are all getting that now. You have to get that crossing. Just you have to get first one is going to cross that second one. Just you have to take this one. It's going to be very clear. And that second one, that is going to be, yes, from this point, just you have to take that 100 and 100. You will get the total distance. It's very clear. We would like to go for this total distance travelled in case of the crossing or in case of overtakes. It's very clear. Yes, we would like to go for that. All right. Okay. Yes. You have to take that case 1, all right. Yes, case 1. What they have given? Simply they have given the time to cross each other and overtakes the second one. Overtakes the other. They have given the time to overtake, they have given the time to cross the first time. It's very clear. We would like to go for this one. Let us take that any of the case. Yeah. What they have given, first data, overtakes. Yes, you have to take that overtakes the other. Simply you have to take that overtakes the other. It's very clear. What about the time? Is equal to 20 seconds. It's very clear. You would like to get this one. So let V1 is the velocity of first one, first train. Very clear. You can get this one. Let V2 be the velocity of second one. All right, it's very clear. We would like to go for this one. Okay, it's very clear. We would like to get that vortex. Here, total distance travelled. Either you have to get the distance or displacement in 1D. It's okay. It's very easy for you. Yeah, you have to get that. That is going to be 200 meter. Okay, we would like to consider a relative velocity. VR is equal to what we would like to consider. This is very important for you. You have to take that overtake each other. Just you have to remember, this is going to be first one and this is going to be the second one. Yeah, it will overtakes that. They are going to be in the same direction. You have to confirm. It's very clear. You would like to get this one. They are in same direction. They have to travel in the same direction. It's very clear. You can take that. All right. Now we would like to go further. Yeah, VR is equal to, you will take that V1 minus V2. It's very clear. This is the first equation. Let's assume. All right. Therefore, you will get that T is equal to d by V1 minus V2. Do you know that equation? It's very clear. You would like to get this one? Yes, you have to take this one. Yes, V1 minus V2, all right. Therefore, T is equal to, T is equal to d by VR. It's going to be identified. It's very clear. You would like to get this one. This is going to be the VR. All right. You know, this velocity, displacement by time, like that only we would like to get this one. All right. So, this is a equation, this is 1, this is 2. Therefore, T is equal to 200 by V1 minus V2. It's very clear. What they have given the time, you can confirm. This is very important for you. Just you have to erase this one to solve the problem, right? All right, just you have to take, this is one case. We would like to go for this, right? Now, it's easy for you to solve the problem, all right? We would like to go for this problem. Therefore, what they have given for overtaking, just it took the time, that is 20 seconds, okay, all right. Therefore, 20 is equal to 200 by V1 minus V2, all right. It's very clear. You would like to get this one. Okay, it's very clear. So, you are going to get this one, that implies V1 minus V2 is equal to 220 by 200 by 20. Therefore, V1 minus V2 is equal to, yes, you have to get this one. This is going to be, you can take that. This is going to be 10. This is the equation number 3. All right, just you have to get that. Have a look into that calculation part and easily will find out that. Okay, all right. This is one. We would like to go for that. So, time taken to cross, time taken to crosses each other, crosses the other. It's very clear. That is T is equal to 200 by VR. Yes, in that case you have to take that, they are going to take that, it's very clear. First one is like that, no? In this way we would like to confirm, this is very clear. This is going to be getting that, crosses. Yes, they are going to cross, yes. So, VR, this is going to be V1, V2, let's assume. So, VR is equal to V1 plus V2. This is very clear. We would like to go for that. So, this is going to be T, what the time? You need to take that. This is very clear. Would like to go for that. Oh, okay. This is very clear. So, what the 10 second is equal to 200 by V1 plus V2 in the, okay, V1 plus V2 is equal to 20. Yes, what we have obtained, this is going to be that fourth one. We are going to measure that relative velocity, so that we have taken all these steps. The first one and second one, you have to see that this is the case we would like to consider all of these, okay, all right, okay. What we have obtained finally, so that is going to be identified. It's very clear, V1 minus V2 is equal to 10, V1 plus V2 is equal to 20, all right. You can solve these two equations So what you will get that now, if you are going to add that, that implies 2V1, just you have to take that 2V1 is equal to 30. All right, it's very clear. V1 is equal to, just you are going to add that, you can get the cancellation. V1 is equal to 15 meter, just you have to take that. Yes, yeah, it's very clear. What about V2? It's going to be easily you will find out V1 is equal to 15. Just what about you will substitute in either of that equation. So V2 is equal to 5 meter per second. It's very clear. Okay, let's have look into that matter. Yes, if you are going to get this one, C is the correct answer. You will get that. This is very clear. You have to take this. Okay, what we have written. Just we would like to erase some part to have that clarity. It's very clear. We would like to go for. All right. Yes, from all these we would like to choose. Okay, have the look into that matter. 15 meter per second and 5 meter per second. Just you have to take that. Okay. Okay, students, just you have to solve this model. In this method, we will solve the problems, right? Yes, so you have to take this one. The numerical ratio of displacement to the distance. This is very important problem. You have to take that. Yes, you have to take that always equal to 1. We would like to have the chance to discuss about all the options. It's better for you. Yeah, generally we would like to, yes, yeah, distance is greater than the, if you are going to take that 1D motion, yes, 1D motion. So, yes, you have to take this one. It's very clear. Yeah, the distance covered by the body. Yeah, you have to get that. So, distance and displacement both are going to be equal. What we have discussed. All right, it's very clear. So, you will take that displacement by distance. Oh, they have given that displacement by distance. It's very clear. You would like to get one. All right, it's very clear. We would like to go for this one, 1D motion. Okay, you have to get this one. Okay, next one. It is only that having the possibility in case of 1D, it is going to be 1. All right. Suppose you will go for this one. Maybe they are having the chance to get the numerical ratio that is going to be less than or equal to 1. You have to get. If you are going to get this one, okay, yes, you have to get that. This is A and B. Yes, you have to take that. Distance is equal to, distance is the actual path. Distance is the actual path followed by the body. Yes, actual path. We have to consider this. Okay, let's assume. You would like to confirm that is going to be the displacement. Yes, this is going to be the displacement. This is very clear. We would like to get this one. So, in this case, you have to get that. Yeah, we would like to go for this. Yes. Displacement is the shortest path which follows. In what direction does you will get that shortest path? That's what you have to get, that shortest distance between these 2 points, between the initial and the terminal. Just you have to get that displacement. It's going to be shortest path. In case of 1D, both are going to be equal. It's very clear. There is no discussion at all. So, always they are going to be equal. But they have not given it is 1D. It may be 1D or in other direction. Just you have to get this shortest path. Okay, you will take that displacement is less than that of distance. Yes, or you agree? This is very clear, we would like to go for that. Therefore, displacement by distance, you have to take this. It's going to be either equal to 1 or less than 1, never greater than 1. You have to get that. There is no possibility always less than 1. In case of that 1D motion, they are going to be equal, we have discussed. So, this is the correct one. Displacement by distance, they are going to be, yes, yeah, you have to take this one. This is going to be having the ratio. Please getting this one. Everyone has to find out this one. Please have a look into that matter, which is going to be clear. Okay, students, in this way we will analyze that problem. We can solve the problem, and while you are going to answer the theoretical questions, just you have to look into that matter and look into that possibilities and guess the, and don't guess that, no, you have to think, you have to analyze and give the answer. That is the correct method. Let's go for that. Yeah, what happened? In 1 second, a particle goes from one point to another point B, moving in a semicircular. Okay, it's very clear. Yes, this is going to be A and B. All right. What about that semicircle radius of 1 meter? It's going to be 1 meter. All right, very clear. The average speed, easily you will find out that V average, that is going to be, yeah, what is the displacement? Just you have to take that now. Yes, the total displacement is going to be getting that. That is, this is going to be 1 meter plus radius of 1 meter moving in a semicircular path. Just average speed. Just you have to get that. It's very clear. It's going to be 2 pi r by 2. Yes, you have to get that. In 1 second, it's going to be getting V average is equal to D total by time. Just we will get this one. That is going to be 3.1 into 1 meter per second. It's very clear. You would like to get this one. While you are going to talk about that average speed, just you have to take this is the total distance. It's going to be total distance. Very clear, we would like to go for this one. All right. So, it's easy for you. Yes, you have to take this one. All right, we can solve the problems in this method. Okay, students, you would like to go for this one. It's very clear. We can easily solve this problem. If in the same problem, if they have given about that average velocity, what you will do that? Now you have to get that displacement. It's very clear. So we will conclude this one. V average is equal to, just we have to take that total distance travelled by, just you have to get that total distance travelled by total time. By total time, we have to take that total time taken. Yeah, in order to reach from one point to another point, it has been followed that semicircular path, no doubt at all. It's very clear. This is going to be the final one. This is going to be that initial point. Yeah, it has been reached in that. Do you know, this is going to be the radius. Yes, you have to get that. In case of circle, you have to get that 2 pi r. We have to get that 2 pi r. It's going to be the circumference for a complete revolution. So 2 pi r by 2. Semicircle, in case of semicircle, distance covered, it's going to be is equal to 2 pi r by 2. It's very clear. This is way, that's what we have taken. Okay students, in this way we can solve the problems. Thank you very much. Have a nice day.